All right, guys. So chapter 7, okay, is now going to focus more on the linear equation stuff, right? The graphs, making equations. So this first lesson is just a quick review of what you already learned in grade 9 about graphing a linear line and what you know about slope. So basically y equals mx plus b. You guys all remember y equals mx plus b? So y equals mx plus b is in the form that the m represents your what? Slope, and the b represents your y-intercept, okay? But it has to be rearranged for y equals, okay? That's important. So pretty much everything in grade 9 was in that form, right? So then you moved forward. In grade 10, it's not going to be always in that form, but you guys have the algebra skills to always make it so it looks like a grade 9 question. Okay, so that's kind of a little intro of where we're headed. So for this first one, it just says the point 4, -1 is on a line that has a slope of 1/2. List 3 other points on the line, graph the line. All right, so do you guys all agree you know how to plot the point? With the slope work that we did yesterday, can you guys all visualize how we're going to get the other points? Right, so we can plot the point that we're given. So let's all plot that. So just a reminder, when you guys plot points, the input is where you go horizontally, yes? So we're going to go over to 4. So we start at the origin. So the origin is at 0, 0. So when you plot a point, you start at 0, 0. The input is how you move horizontally. So we're going to move 4. And the output is how you move vertically. So we're going to move 4 to the right and then 1 down. Because I always assume students remember how to plot ordered pairs, and sometimes I have students do it backwards. So I just wanted to make sure that we're all good with plotting points. So again, so plot our point first. So 4, 1, so over to the positive 4 on the x-axis, down 1. So that's my original ordered pair. Okay, so that point I have. So it wants us to calculate 3 other ordered pairs. What is our slope again? 1/2. So since our slope is 1/2, that means the 1 represents a what direction? A rise direction. And the 2 represents a run. Okay, so we're going to rise how many from that point? 1. And we're going to run 2. So not that you're going to do this, but are we basically making little stairs? Don't write this in there. Okay, but at the end of each little stair is another dot. Exactly. Do you guys agree that those are all ordered pairs on this line? Could we go the other direction? Yes. If we did a slope of 1/2 in the other direction, it would have to be a -1 and a -2. So if we wanted to go in the other direction, I would have to, instead of go up, I would go down and back, right? Because down and back means a negative and a negative, which is a positive. So could I go down and back as many times? Yeah. So I know I only wanted 3, but this is what you're visualizing. Okay, that's how we're getting our line, is doing our slope from a point. So do I have a lot of points now? And those little staircases I just built, are they imaginary? Yes, those little green parts of my staircase aren't actually there. That's what you're visualizing to get all your points, right? So you can, as long as you have 1 point and a slope, you can always graph a line, okay? So therefore, can we take our our pencil and just away we go? Yeah, so go ahead and draw your line through. I am not super picky, guys. You don't need to use a straight edge, but please do the best you can. Okay. So that's pretty good. So you guys pick which points you want. Pick any 3, because how many do we have actually now? 2, 4, 6, 8, 10, so 9, because we can't use our original point. So pick any 3, I don't care. So I'm going to use 0, -3. I'm going to use 6, 0, and I'm going to use 8, 1. So that idea right there, guys, of having a point and a slope is how we're going to focus on graphing lines this year, okay? Well, one of the ways. We're going to kind of focus on 2 different ways. So this is kind of our main way that we're going to focus is finding a point, and specifically the point that we're going to use 9 times out of 10 is our y-intercept. Did we use our y-intercept for this one? No. Okay. But we could have if we had more information. But let's see here. On your graphing calculator, graph y equals 1/2 x minus 3. What do you notice about the 2 graphs? So we're not gonna focus on our calculator today, but I'm gonna at least show you where to graph on your calculator today. We are gonna focus more paper pencil, but you guys did spend a lot of money. So if you have a graphing calculator, get it out. If you don't, that's okay, you can watch, okay? Or you can borrow one of mine. All right, so if you have your graphing calculator, okay, and like I said, if you don't, you can see it all here. All right, so if you've been, and I do have some on my desk as well if I run out of over there, okay, so if we want to graph this on our graphing calculator, okay, do you guys agree that our equation is in y equals form? Is there a y equals button on the calculator? So if you look at the calculator, okay, the very top there, first button that you'll see right in the corner, okay? So this is where you'll put all your equations that we graph in the next 3 years, okay? 10, we don't use a ton of the calculator for extra funky stuff, but next semester we'll use it a lot, okay? So I'll just show you the basics this semester. So the basics of graphing, you're going to use your y equals screen, so everybody hit y equals. Is everybody at a screen that looks like this? Everybody's there? Put up your hand if you're not there. Okay. So if you're using one of my calculators, you might have information in there already. So if you have stuff on the lines, just take your cursor, your up and down arrows, and just hit clear. So let's pretend I'm just going to put something in. Don't write this down. So if I have something on there, I want to get rid of it. So just use your cursor, go to that line, and just hit clear, which is right under your down arrow. And it'll clear the line. So we want it all blank. So everybody has all blank, y1, y2, y3. So all those y1, y2, y3, all the way to y9, I can put 9 equations in at once if I wanted to. Okay, there actually, I think it even goes further. I don't actually know. I've never put more than 4 in. Yeah, so there's 10. So I can put up to 10 equations and graph them all at the same time. I've never done it, but you could if you wanted to. Okay, so it doesn't matter which line you use, okay, to put your equation, and I just use y1. But again, you could put it on y6. It's just going to graph an equation. So how we're going to type this in to y1, okay, the slope I'm going to put in brackets, okay, just because it's a fraction. If it was just a 2, I wouldn't. But since it's a fraction, I'm going to put brackets are right above the 8 and 9 button. Okay, do you guys all see them? So you're going to hit the bracket button right above the 8. And then you're going to type in 1. Then you're going to hit the divide sign, divided by 2. And then guess what I'm going to do after that? Close my bracket. So hit the button above the 9 button. So right there. Now, what variable do we need to put next? An x. So some of you might have discovered, did you guys see the x right above the store? Right above the 2 above the on? That's the long way of getting it. You could go alpha store and get the x, okay? But way too complicated. See the button right underneath the mode? It says xt theta n. That is your shortcut x button. That's the button we're going to use for the variable when we graph. Your calculator only accepts x's and y's when we're graphing equations, okay? So even though, which we learned in function notation, right? If I have a h equals, is that still the same as y? Is it still an output? So yes. So if there's different variables, you still use x and y, okay? So if you hit the xt theta n button, That's your shortcut, fast way of getting an x. Okay? Instead of going alpha, because again, this would have worked. If you went alpha store, it would have got you an x as well. But too many buttons. I need to delete one of them now. So everybody has 1/2 x on their calculator that has one. So guess what I'm going to type now? -3. Now, before you hit graph, because did everybody see where it says graph? That's what we'll hit in a second. But I don't want to yet, just because if you're using some of my calculators, okay, we all might have different graph paper. Because do you guys agree graph paper matters depending on what we're graphing, how big and how small it is? So I want this graph paper. So this is called a standard window, which is a -10 to +10 on both axes. So we can manually input this. You can manually input any graph paper you want. And it's instead of called graph paper, it's called a window. See where it says window right beside y equals? That is always going to be the dimensions of the graph paper that will be on your calculator. So everybody hit window right now. Okay. Your window might not look the same, but did everybody get something that looks like this? So right now, just to show you, guess what my x-axis is right now, my calculator. My x-axis is going from 0 to, no, mine isn't. Mine is going from 0 to 24. Guess what this represents? The XSCL scale. So my calculator, yours could be different. My calculator is going from 0 to 24 on the x-axis, going up by 1s. My y-axis is starting at 0 and going up to 10, right? And scale is 1. Does that match this graph paper? No. So, two ways that you can do this. We can manually, I'm going to manually enter it in right now, but there is a shortcut button that will automatically do, because this is called a standard window. It's a window that we use a lot. If you do a zoom 6, right? Zoom 6 gets you this window automatically. But I just want to show you guys, you can manually enter it in. So if I wanted to go -10, please don't use minus. It has to be the negative button right beside the enter. So you'd go -10 to 10. So I'm just typing in the numbers. Scale, I want to go up by 1, so I'm going to leave that. Y, I want to start at -10. So again, this is called a standard window. It's a window we use a lot. We do adjust it. And then we're going up to 10. X resides, ignore that. That's just how fast it graphs. If you speed it up too much, it sometimes makes it look like not a straight line. All right. So does everybody have a standard window? So everybody hit graph. Okay. So on your calculator, okay, you have, see right above graph, guys, guess what that word is? Well, you can see it. What is the word? Right above graph, what's the word? Table. Guess what that represents? Table of values. So if you go second graph, you have a table of values. Yours is going to look hopefully not like this. I've been doing trig, so my scale is different. So if you're using one of my calculators, listen up. I've changed my table because it made more sense to go up by 30s. Does it make sense to go up by 30s with this one? No. So if you have one of my calculators and you want to go back, you're going to follow me. Yeah. So then you probably use the minus sign instead of the negative sign when you did your window. Oh, you didn't change it? Okay, then let's take a peek what happened. So it's definitely, so you didn't change this at all? No, that looks good. So then when you went into what? Oh, sorry. Thank you for letting me know. That has to be turned off, which you would not know. Guys, listen up. So many things to remember to tell you guys, especially if you're using, listen up, because this could have happened to some of you guys. Please make sure, I forgot to mention this, normally I remember, is anytime you grab one of my calculators, just because I'm doing so many different things in all my classes, if you ever see one of these highlighted like that, you need to turn it off just because your calculator will get confused and kick you out. So if you didn't get kicked out, those are probably all not highlighted. So if you end up using one of my calculators and they're highlighted, all you have to do to unhighlight it is use your arrow up and just hit enter on it, and it unhighlights it. Because we're looking at lists. You're actually going to use those plots this year, so you'll actually know what they're doing. But for right now, I just need you guys to know to turn them off. So if they're highlighted, just use your up arrow, hit enter, it'll turn it off.
Oh, I can print infinite points if I scroll.
Yep, so now for those ones that have a yucky table, and all of you should listen for this, because depending on what graph you're doing, do you think going up by ones won't make sense sometimes? Yeah. So if you want to change your table so it doesn't go up by ones, or for me, I want to go back up to ones, it's here in your table set. So I know this is a lot of information, guys. I don't expect you guys to remember everything I said today about your calculator. I'll say it a lot. So if you go second window where it says table set right there, this is where you can tell your calculator to do whatever you want in your table of values. So right now, my table is starting at -60 and going up by 30s. Does that make sense for this equation? No. So then I would say, no, I don't want to start at -60. Let's start at, say, 0. And then I want to go up by ones. If you change this to ask, then you can type in your own numbers. The table will be blank. Okay? So if you change that, like I said, instead of to auto, to independent to ask, that table will be blank and you can type in whatever input you want and it'll give you your output. Right? But don't put auto or ask for dependent because you want it to calculate it for you. So now if you go to your table, everybody should have the same table. Does everybody have the same table?
Yeah, I'm like one part of
Where it says table. So anything that's on the face of your calculator in blue, you have to hit second graph. Right? But believe it or not, guys, we're not going to use a table of values this year. That's going to be the long way of doing it. Okay? But you guys have it. You have the table of values. Could you pick points from there now if you wanted to? Absolutely. All right. And the other thing I wanted you guys to notice, go back to graph. Okay? Do you guys, is that the same graph as we just did there? Yes. It is. So I want you guys to make the connection, okay, that this equation right here that I built, you will be building them, okay, can you guys make the connection that that equation matches this graph? Because this equation has a y-intercept at where? -3, so look at here. Does this one have a y-intercept at -3? So it's just looking at another point, and then from there I could go up 1 over 2, up 1 over 2. So that equation does match this. We will be building equations, not today. All right. So here it just says use the line graph below, answer the question that follows. So what are the slope and y-intercept of the line shown in the graph? So here, the one that you should be able to get very quickly just with your eyes with no calculations whatsoever is the which one? Y-intercept. Should that have 0 calculations? Yes. So if I give you a graph, you just literally take your eyes, look on the y-axis where the line crosses it. Right? So then we know that the y-intercept is 1. So if I write the y-intercept, not that you have to, but if I asked you to write the y-intercept as an ordered pair, what would the ordered pair be? 0, 1. Do you agree, guys, that for any y-intercept in the world, your input will always be 0? Yes, that's an important piece of information. Okay? To get a y-intercept, x is always 0. All right, so slope. Slope is pretty quick as well. It's just a little bit of work, though. Right? So to be able to figure out slope off a line, how many points do I need? 2. So is there lots of points on there? So you just find 2 nice ones. Okay? So I'm just going to put all my nice ones on here just to show you guys. You don't have to put all of them. So technically, so is there, like, without using the arrows, there's 3 nice ones for sure. Do you guys agree? So you only have to pick 2 of them. I don't care which 2. So if I pick these 2 right here, and again, if I pick those 2, like these 2 right here at 0 and 1 and -3 and 3, and somebody picked the 2 outside ones, are we all going to get the same slope? Yes, they all reduce to the same thing. That's why it doesn't matter. Any 2 points on the line, you can count your rise and run. So if I pick these two here, so if I start at the top point, how many blocks am I going down? 2, so it's a negative. And I'm getting to the corner, so at my 90, I'm turning right and counting how many more? 3. So, and it's positive, right? Because I ran forward. So therefore my slope is negative 2 over 3. So negative 2 over 3. And I told you we weren't writing equations, right? But this, I guess we're writing 1 today, but all the information's right in front of us. So technically, since I have the y-intercept and I have the slope from what you guys did in grade 9, can you write the equation of this line? Yes. All I'm saying is we're not writing equations that are going to be complicated today, where we actually have to do a little bit of calculations outside of just looking at a graph, because we are headed that direction. So if I now write the equation, what am I going to substitute in for m? What's going to go right in for that m position? Right? Negative 2/3. And what is going to go in that b position? The 1, right? The y-intercept. So for you to be able to write an equation of a line in y equals mx plus b form, you need slope and you need y-intercept. And then you just put it into the formula. Okay, all of you will get a formula sheet today. Okay, some of you got it yesterday because you showed me your booklets, but all of you will get one. That is on your formula sheet if you forget. Okay, so y equals negative 2/3 x plus 1. So your equations will be written in terms of x and y. Okay. All right. So what I'm going to do now is I'm going to do these example 2 with you. Then we'll stop, we'll write our quiz. And then what you're going to do once I'm finished example 2 and once you're done your quiz, you're going to rearrange these equations for y equals, okay, and graph them. All right. So example 2a, that's grade 9. Do you guys agree? Right. Grade 9 is A, because can you tell me the slope and y-intercept right now? Yes. Okay. So no work involved. You just have to understand y equals mx plus b. So you would tell me the slope is 3 over 4. Would 0.75 work? Yeah. To me, you don't have to change it to decimal form. If you want to, it's equivalent. I don't care. And the y-intercept is negative 7. I like writing it as an ordered pair, but if you just wrote negative 7 there, that would be acceptable. So do you guys see a little issue for B? What do you have to do first before you can answer these 2 questions? How do we define the slope, though? What operation do we have to do first? Nope. Is it in y equals form, where y has a coefficient of 1 on it? That's the thing, guys. For you to be able to use y equals mx plus b, little birdie, okay, y has to have a coefficient of 1 on it. So you have to use your algebra skills to rearrange all of these equations for y equals, okay? So the first one's very quick. There's only one step to do. You have to divide everything by 2, right? So you divide everything by 2. Right, so if we divide everything by 2, now clean it up, don't leave it like that. So 2 divided by 2 is a 1, so we have y equals. You can leave it as 3 over 2, or you can change that to what? 1.5. I like leaving slope as rise over run. It helps me with graphing. And then negative 10 divided by 2 is negative 5. Now can you tell me the slope and y-intercept? Yes. So slope is 3 over 2, and the y-intercept is negative 5. Right, so we're graduating to a little bit more work. Okay, so here, how many steps am I going to have to do before I can get y by itself? I can't do it in 1. I have to do it in 2 steps, because what has to move first? The minus 2x. That has to go to the other side. And then I have to get rid of the 5. So this has 2 steps before I can get y by itself. Okay? Because again, your goal, guys, is this. It has to look, right? So the x term and the constant term have to be on the same side of the equal sign. Are they on the same side of the equal sign right now? No. So we have to do that first. So we have to get rid of the whole term. So if you're moving a whole term, you do opposite operation. So now we have 5y equals 2x plus 10. Could I say 10 plus 2x? Would that be the same thing? Yeah. It's just weird putting the slope term second, but it's the same thing. It doesn't matter. Right? Now I can divide everything by 5. Every term has to get multiplied by 5. Right? So then 5 divided by 5 is 1. Perfect. That's my goal, is to get y with a coefficient of 1 on it. And then my slope, I like to leave it as rise over run, just because we are going to be using these to graph. And then 10 divided by 5 is 2. So then my slope is 2 over 5, and my y-intercept is 2. All right. So far, so good, guys? All right, so then last little one, do we have quite a bit of cleanup to do here? Yeah, so we have to get rid of the brackets, right? So quite a bit to do, so let's get rid of the brackets first. So we're going to multiply the 3 into the brackets. So I'm going to get 2y plus 3x minus 9 equals negative 5. So for this one, I have 2 terms I have to move. Do you guys agree? So I got to move the 2x. There's no 2x. We have to get rid of the 3x to the other side, and we also have to get rid of the minus 9. So 2 terms we have to move. There must be something up there. All right, so are you guys okay with me moving both of them at the same time? Okay. So if I move them both, I have to add 9. It has a like term, so does it get to go with the minus 5? Yeah, so that'll go over. But I also have to move the 3x. So that one doesn't have a like term, so it'll just stay over there. So now I have 2y plus 3x minus 3x is gone from the left side. Minus 9 plus 9 gone from the left side, but they are now on the right side. So I have a minus 3x, because it doesn't have a like term to go with. And then minus 5 plus 9 is plus 4. And again, I know I'm writing the minus 3x second, but are you guys okay that I change position and put it first? Because it doesn't matter. Okay. So then now I can divide everything by 2. So then I have y equals negative 3 over 2x plus 2. So my slope is negative 3 over 2, and my y-intercept is 2. All right, so guys, I changed my mind. After you're done your quiz, don't do anything on this page. Just go to your assignment booklet when you're done and just do up into the graphing. So in your assignment booklet, it'll just be, yeah, so you'll just do page 2 after your quiz in your assignment booklet. That's it.